Windmills have historically been a part of our landscape. Perhaps the most famous ones are in the Netherlands, surrounded by beautiful and colorful tulips. Or maybe one remembers Don Quixote and how he imagined the windmills in Castilla-La Mancha in Spain being giants moving their arms. Whatever your imagination brings when talking about windmills, the truth is these have served as a source of energy for a long time. Today, in the efforts to create green power sources, wind turbines are being installed at a fast pace. But is building as many turbines as possible the solution to our climate problems? Hi, and welcome to Energy Explained in Short, where we discuss all things energy and more specifically, renewable energy. In these In Short series, we will tackle a topic and have a discussion, so you get the bigger picture in a small format. Today, we talk about wind turbines, their efficiency, and the challenge that multiplying the number of renewable assets poses to the current electricity grid. The numbers are clear. In 2022, new wind project installations in Europe reached 19.1 gigawatt, increasing 4% compared to the previous year. This was a record year for installations, despite the uncertain economic environment and supply chain challenges. According to Wind Europe, it is expected that the installed wind capacity will increase on average 20 gigawatt per year from 2023 to 2027, both onshore and offshore. It all sounds great. So, what is the problem? Well, first let us dive into the capacity factor of wind turbines. The power capacity of a wind turbine is the amount of electrical power it can generate in an optimal setting. This is when the turbine is placed in the perfect location. Maybe on a beautiful mountain, or even offshore in the middle of the sea. And there's a constant amount of wind that sweeps the blades so gracefully. With perfect air density and the perfect speed. Among many other things. As you can imagine, this perfect environment is impossible to achieve. So instead, the capacity factor is more realistic in showcasing the amount of power a wind turbine can actually generate. Let's see this with an example. If the capacity factor of offshore wind turbines is generally between 29 and 52%, this means that an offshore wind turbine of, let's say, 2 megawatt produces less than 1 megawatt on average. So if 2 megawatt can be achieved, but less than half is what we actually get, does this mean that wind turbines are not efficient enough? Well, not really. The reason why the capacity factor is that low is tied to the availability of the turbine. This means that the turbine is stopped or curtailed. So, if we can find ways to avoid stopping our turbines, we increase the capacity factor, right? And that turns our eye to why wind turbines are being stopped. Well, this is quite a hard question to answer because there's multiple reasons why this could be happening. First reason is inadequate weather conditions. So simply because there is no wind. But too much wind can also be an issue, as sensors can shut the turbine down for safety. Extreme weather like ice or heavy rain can also be an issue. The second reason is environmental regulations. This is mainly to protect wildlife, but can also be to reduce noise. Wind farms are obligated to install monitoring systems that allow them to detect movements. And by stopping the turbines, safety is ensured for the birds and bats, and potential turbine failures are also prevented. The third reason is maintenance and service. It can be because the turbine is not working optimally or some parts need to be updated or changed, as small failures can significantly affect performance and reliability. So owners will opt for stopping the turbines, servicing them, and then running them again. Our fourth reason is avoiding negative prices. Sometimes if there is a lot of wind, then a lot of power is being generated, but there is no demand for it. Renewable sources are the cheapest energy sources, so if all of the demand is covered by renewables, and on top of that there is a surplus, prices will drop even to the negative, which means that power plant owners have to pay to send power to the grid, which is why they choose to stop their turbines instead. And on to our last reason, but definitely not least. One of the main reasons turbines are stopped is to maintain balance at the grid. And that's what we will be talking about today in the discussion. So we talk about the balance of the grid a lot when discussing energy and renewables especially. So this is our topic for a discussion today, Kirstine. Why is balancing the grid so important?
Well, the reason we talk about it so much is it's because it's the basis of one of the biggest challenges of renewable energy. Power production and power consumption must always be balanced. So if there's more production than demand, there's a risk of the entire system shutting down. And if there's not enough production compared to the demand, then there is a risk of blackouts. So it's crucial that the balance between the two is stable.
Yeah, so this reminds me of a particular story that involves football and kettles, isn't that right?
Yes, so the story is actually of when Britain experienced their highest ever spike of electricity consumption, which was a spike of 2,800 megawatt in one go.
Yeah.
And the funny thing about this story is that it was recorded in 1990, right after England had lost the Football World Cup semi-final in penalties, as they always do, against West Germany. So all the Brits went to turn on the kettle just after the match, and this was equivalent to 1.1 million kettles that were turned down just at the same time, right after the match was over.
Yeah, I guess the Brits really like their cup of tea.
Yeah, they do. And the grid operators really had to be aware of this because maybe they hadn't seen this in their forecast that this would happen. But they need to do this because they need to forecast the demand and supply very precisely. And they need to do this to maintain the frequency. That's kind of like the basis of this whole balancing.
Which, by the way, is different depending on the residential supply standards of each country. And in this book that we absolutely love, which is called Visual Guide to the Power Grid, they explain how in Europe, the Hertz, which is the measuring unit of frequency, has to be at 50 for the grid to be balanced. Whereas it has to be at 60 in the US. So, and why is that? That's because Nikola Tesla calculated that a frequency of 60 Hertz was a good measure for arc lightning bulbs, which were most usual at the time. So that was the measurement that they established in the US. And then at the same time, AEG, the German electrical company, chose to set the European standard to 50 instead. And that's how it still is now. So North America and parts of South America have the 60 years, and then Africa, Europe, Asia, Oceania, they all have the 50 years. And I think it's interesting how something so crucial, because we're talking right now how balancing is so essential. So yeah, something as crucial as setting the frequency of the grid was so arbitrary.
Yeah, and maintaining a stabilized frequency is what balancing power is actually all about.
Yeah. And how could we explain how the frequency works.
Yes, and Munia, we're actually really lucky here because we have a very good colleague, Jan Lindholt, who has this analogy about cruise control.
Jeg plejer nogle gange at sammenligne det lidt med fartkontrollen i bilen. Jeg har sat cruise control til 50 km i timen, det er min frekvens. Hvis det begynder at gå lidt op ad bakke, jamen, så er jeg nødt til at producere lidt mere, det siger jeg er nødt til at trykke lidt hårdere på speederen. Det gør.
What Jan is doing here is actually comparing frequency control to cruise control. So when driving a car, he explains how if you set the cruise control to 50 miles per hour, it will automatically regulate and ensure that the speed is always 50 miles per hour. So if I'm driving and it starts going slightly uphill, then the cruise control increases the pressure on the accelerator to keep up the 50 miles per hour speed. And then if it starts going a little bit downhill, then it will remove the pressure from the accelerator so it doesn't suddenly drive too fast.
Yeah.
And it's kind of the same concept with frequency control. Here, a TSO, which is a transmission system operator, will ensure the balance by sending out these set points to power plants that these power plant or the owners of the power plants, they need to comply with in order to ensure this stable frequency.
Yeah.
And then it's actually up to the local power plant controller to adapt to these set points.
Yes.
So that's how it works.
Yeah, exactly. So then our main issue here is that we can't control the production because wind is a fluctuating energy source. So we need more flexible consumption. And in our first episode about solar and storage, the power couple, we talked about this exact thing, how storage or PTX technologies could serve as a way to convert the surplus energy into ready-to-consume energy for later, and that is what can be considered some flexible consumption.
Yes, and this actually means that the need for stopping wind turbines, which you started out talking about in this episode, becomes smaller. So if we don't need to stop wind turbines so often, then the availability increases and so does the capacity. But here, of course, it's important that the renewable plant owners, they're able to control the renewable plants, but also able to actually control the demand side of, or at least have a way to control where the power should go. You know, should it go to the transmission grid, distribution grid? Should it be stored in the battery system? Should it be sent for PTX plant? There are a lot of opportunities.
Yeah. Yes, and then on top of this, I think we could also say that there is a need for a smart grid, one that enables the efficient integration of renewable energy sources, but it also increases grid flexibility and it promotes energy efficiency, as we're talking about right now, conservation, provides a reliable and resilient energy infrastructure that is also environmentally friendly. So, yeah.
And this, you know, utilization of the energy and hybrid power plants, it's a big topic in the renewable energy industry right now.
Yeah.
And we can see that people are looking for solutions that give them that flexibility you were just talking about.
Yeah, I think that was a fruitful conversation. Yeah, so we can wrap it up for today with these final thoughts. Thanks again, Kirstine, for...
Yeah, go hybrid.
Yeah, go hybrid.
Yeah, thank you, Munia.
Thanks for listening to the Energy Explained in Short series. If this episode was interesting, follow us and stay tuned for more to come in the future.